Hello friends, welcome to my channel. Let's have a look at the daily challenge problem. That is problem 2007. Find original array from doubled array. So in this video, we're going to share a solution based on sorted container. So first I'll read through the statement of the problem to digest the key point, and then we do a simple analysis, and finally we share the code. First, let's look at the statement. So an integer array called original is transformed into doubled array changed by appending twice the value of every element in the original array, and then randomly shuffling the resulting array. So given an array called changed, so return original if changed is a doubled array. If changed is not a doubled array, return an empty array. So the elements in the original may be returned in any order. So that's the main statement of the problem. Here are three examples. So example 3 is sort of trivial because it contains only one element in the changed array. So the length actually is not even. So it should return empty one. So in example 1, so the return is false. It's not a doubled array. So in example 1, so the return is true. The return is 134. It's true that the changed is a doubled array. So the original array can be 134. So if we double it, so we get 268, and then together we get this one. So that's the three examples. So now let's look at the constraints or additional assumptions. So first, the length of the changed array is bounded above by 10 to the power 5. So this constraint actually defines the problem size. And the second one, which is important for our solution, is that changed I, so each of the elements in the changed array is not negative, and it's non-negative, we may see. So it has an upper bound, but here it's not negative, is important for us. So with that said, so we are ready to look at the method. So this problem actually is not trivial. So it's marked a medium in Leetcode. So the method here, or the solution, is based on sorted container. So here we use sorted list to fix the idea. So the key observation for this problem is the following. So if changed were a doubled array, then the largest element x in it must be an even number, and the half of this element must also in the array and has a frequency no smaller than that of x. So that's the main observation. Here is also a special case, which is 0. So 0 is special for multiplication because 0 multiply anything is 0. So if 0 is in the changed array, then 0 must appear an even number of times so that the changed can be a doubled array. So with that said, so we can do the solution using the following procedure, so which is a specification of the above observation. So we could use sorted container or heap to help construct the original array. So let's call the original array original. The step is the following. We initialize a result array, so originally empty, to hold the elements. Then first we find the unique value and their frequencies. So this can be done easily using the counter object. So which is counter is a subclass of the vanilla dictionary in Python. So the second step is to construct the sorted list keys of the keys, or in other words, the unique values. So in step 3, so we're going to do the following thing. So we first pop from the sorted list keys. So this way we get the largest element. Then we check if the largest element is 0. So if this largest element is 0, then we check if count x, or in other words, count 0 is even. So if it's not even, we're going to return empty list because it cannot be a doubled array. Otherwise, we extend the result with a number of 0. So this is the specific number, so count 0 over 2, right? So if the key is not 0, in other words, the largest key at the present time is not 0, then we want to make sure x is an even number because it's twice of some element in the original array. So if actually it's the largest element in current largest element in the original array. So if x is not even, or the count of half of the x is less than the count of x, in other words, we do not have enough x over 2 to match the count of the largest element in the original array. So we're going to return empty array because in this case the array changed cannot be a doubled array. Otherwise, so we're going to extend the result with a number of x over 2's. So the specific number is nothing but the count x, the frequency of capital X. Then we're going to decrement the count or frequency of x over 2 by that of count x. Then we want to check if the count of x over 2 is 0, then we are going to discard or remove x over 2 in the arrays. Then we continue. So finally, we just return the state of the result. So that's the way. Here is a very quick walkthrough. So this is changed. So the length is 6. So the largest value currently is 4. So if we do the count, we know 1 appears once, and 2 appears 3 times, and 4 appears twice. This is the sorted list, right? 1, 2, 4. Then if we do a pop, so we will get the maximum key is 4. So this 4 is an even number, and it appears twice here. Then we are going to update the result by extending with half of this key, that is 2, by twice, 2 times, so that's 2, 2. Then we're going to update the count by decrementing the count of 2. In other words, 4 over 2, right? So originally it's 3 times because we used it twice, so we used 3 minus 2. So the count of 2 is 1, and 1 is still 1. Actually, we can update this 4 key, but it's not necessary. So in this case, the key will be 1, 2, right? And then we do the pop again. So the current maximum key is 2, right? It appears once. Then we know 1 is also in the count appears once, so we update the result by adding a 1. And then the count of 1 is 0, and 2 is 0, right? So in this case, actually, the keys will be 0. The reason is that we popped once, and also because the count of the 1/2 of the key, that is 1, is 0. So we actually discard or remove this key. So overall, the return is 2 to 1. So here is a note. So note that we do not need to update the count each time we consider the maximum key popped from the sorted list, right? So the key thing is that we update the available keys in the sorted array, but it's still okay if we like. We can update a count to a clean state. So with that said, actually we are ready to translate the above procedure into code, which is straightforward. Before we do that, here's an extension. So can you try to write a solution format using heap or sorted dictionary? So with that said, let's do the code for this problem. So for convenience, I imported the sorted list. So here in this solution format, we're going to use sorted list. The reason we do not choose to use sorted dictionary is that we feel that the key thing is the sorted list in this format. So first, I'm going to do the counting, right? So we want to find the unique values and their count. So we're going to use the collections counter class. So changed. So this way we get the unique values and their corresponding frequencies. And then we get the keys. So the keys, we're going to use it as sorted list. So from the count keys. So then we're going to initialize a result variable. Let's call it empty. So this is the preparation step. So next we are ready to construct the original array if it were a doubled array. Otherwise, so we actually return empty array. So here, well, keys. So if this is the case, let's first get the maximal key, that is keys on pop. And then what we are going to do is that we want to check if k is 0. So this is a special case, right? If k is 0, so we want to check if count k is even. So in other words, so we check if it's 0 or not. If it's not even, so we actually just need to return empty, right? Otherwise, so we need to extend the result by a number of zeros. So, or let's see, the zeros will be this amount. That is the count of k over 2. So actually the k is 0, right? Here you can also write 0. So then we're going to discard this 0. So this is for the case when k is 0. Otherwise, so the k is not 0. So then we want to check if the k is even. So if it's not even, so it cannot be a multiple of some multiple by 2 of some number. So we return empty array. So otherwise, so it's even. Then we're going to check if the count of k over 2. So we use get. So if the k over 2 does not appear in the count, we set it to be 0. So if this number, this result is less than the count of k, so not enough, then we're going to return empty array. So here we missed a if. Alright, so next, so in other case, so we're going to extend the result with a number of k over 2. So the number is nothing but count k, right? So we don't need this bracket, so here, because we do not divide by 2. So this is the extension. Then we also need to update this one by minus count k. Then if count k over 2 is 0, then we just need to discard this one in the case discard k over 2. So this way, after we exit this while loop, so either we have returned empty array, so or we finished building the original list or array, so from large to small actually in this procedure. So we are just ready to return the result state. So that's the full format of this solution to the problem. So let's do a special case check. Does match alter annotation? Let's see. Return. So let's check again. Yeah, it passes the example we cooked up. Let's check this one before we do the generic case check. Yeah, so our output is 431 from large to small. So actually we can devise method to return the result from small to large. So now let's do a generic case check. Yeah, it passes all the generic cases. So I guess that's about it for a solution to this specific problem. Let's give a quick summary for this video. So in this video, we built a solution based on sorted containers. So here we're using a sorted list. So actually you can try to solve it using sorted dictionary. So it's not necessary in fact. Or another way, so you can try to solve it using with the help of the heap abstract data structure. So with that said, I guess that's about it for this video. Thank you very much.